There are three main types of rock which are visible on the Earth's surface: magmatic, sedimentary, and metamorphic. We're going to do some basic triage and see if we can classify a rock sample. I have selected a large sample, about the size of a fist, so that it is representative and will show any larger scale details. It also has a very fresh surface, without weathering or dirt. This rock feels not too heavy, so the density is probably about medium. It is hard and not friable. I cannot split or break it by hand. Now the visual inspection. First, with the naked eye, I can see the rock is light-colored and matte overall, but it is not homogeneous. It has some shiny and dark constituents. There is no obvious visible structure, and the rock looks similar from all angles. Looking more closely at the constituents, we can see that they are all generally between 1 and 5 mm across. Let's get a closer look at those constituents under the hand lens. Immediately I can see that the visible constituents touch perfectly and do not have any other material between them. They are distinct and some have recognizably geometrical shapes. This indicates that they are minerals and will help us to identify them. Black minerals appear on the surface as large, shiny, near hexagons or as small, thin needles. This tells us that the crystalline shape of the mineral is a hexagonal flake. They are distributed through the material in all orientations. This is black mica or biotite. There is another shiny flake mineral present, which is paler in color, translucent and silvery. Its pale color makes it harder to see when it is edge-on to the surface. This is white mica or muscovite. Much of the remaining space is filled in with a matte white mineral. In some places it achieves a nearly rectangular shape, characteristic of feldspars. The final mineral is a translucent gray, which is for the most part irregular, but occasionally shows the hexagonal polygon cross-section of its crystalline shape. It has a glassy surface, which is reflective, but without the clear planes and striations of the mica flakes or feldspar crystals. This is quartz. Now for our conclusions. Because the rock is entirely composed of minerals which have grown together from magma, it is a magmatic rock. The magma was able to separate completely into different minerals with no matrix of leftover material. So we can conclude that it formed at great depths and is plutonic. Because the rock is made up of mica, feldspar and over 1/3 quartz, we can identify it as a granite.